Hello! This video is a series of 5 videos in which we will compute the performance of a 24-slot 8-pole spoke motor using the transient magnetic solver of EMWorks2D. In this part, we will investigate the no-load performance of the 24-slot 8-pole spoke motor, more specifically the flux linkage and induced voltage under no-load conditions. First, we will start by creating a new study and name it no load. Change the analysis type to transient. In the solution type, check compute circuit parameters to compute the inductance and flux linkage. Enter the end time, which will be 1 divided by the frequency 50 Hz to simulate one period, and it's recommended to divide it by 30 so that we can simulate 31 steps. In the coupling analysis, check rotational motion. Angular velocity 4500 degrees per second is obtained using the shown formula. The rotor angle is defined as a global variable in SOLIDWORKS. Select the rotor subassembly in the moving components and the band part in the band component. In the 2D geometry tab, select the coordinate system and set the model length to 50 mm, then click on OK. To save time, it's recommended to copy and paste the materials from the previous study since no change will occur. To do so, right-click on the materials from the cogging torque analysis and choose Copy Material. Then, right-click on the materials in the no-load analysis and select Paste Material. You can also use the drag and drop option to copy and paste the materials. In the same way, copy the load restraint defined as the null magnetic vector potential on the outer aeration edge from the previous study to the current no-load study. Copy the forces torques from the cogging torque study and paste it in the no-load study. Copy the mesh defined in the previous study. It's to be highlighted that the mesh defined in the previous video part is a recommendation to save the simulation time. To define the windings, right-click on the Windings folder and choose Stranded Winding. Name the first winding as Phase A, keep the coil type as current-driven coil and the number of parallel paths as 1. The spoke motor windings are not excited in the case of no-load operations. Thus, keep the DC current source magnitude as 0 ampere. You can click on Keep Visible to keep the Phase A winding properties when defining both the Phase B and Phase C windings. To create the in and out coils corresponding to each winding, right-click on the Phase A, choose Wound Coil, then Surface. In the Select Entities tab, select the coil surfaces for which the in coils for Phase A are defined. In the General Properties tab, name the coil as A+, then define the number of turns as 30. Click on Keep Visible to define the out coils for Phase A. Name the out coils as A- and select Reverse Direction. Then select the corresponding surfaces. In the same way, define the in and out coils for both phases B and C. Right-click on the mesh folder to create the mesh and verify that the accurate curvature representation option is checked, then click on OK. Now right-click on the study and select Run. The study is now solved. To check the flux linkage, right-click on the results table and select Show. Choose flux linkage from the results table. Select Add, then plot preview to see a preview of the no-load flux linkage versus time result. In the same way, choose Induced voltage from the results table. Select Add, then plot preview to see a preview of the no-load induced voltage versus time result. To check the magnetic flux density mapping, right-click on the magnetic flux density plot and select Show. Now, as we have reached the end of this part, well done, and see you in the next part.